thought I'd give you a good practical example of what you can do with a graphic user interface and some simple drawing commands. We'll set up a menu bar and we'll create a frame, and inside of that frame we'll do some drawing. And the drawing is going to be altered based on the menu bar selection. We'll have a main menu bar that we'll set. We'll use a simple grid layout with only one item, and we'll add the so-called Snell and Wilcox pattern here. The Snell and Wilcox pattern is really just a panel that allows you to do a variety of different painting, and the painting is based on this rather long dispatch, which determines which pattern you want to draw. And you can control the test pattern and do a variety of different drawing programs. You can draw a grid, you can draw white, you can draw black, draw chip charts, pulse bars. I'll show you what this looks like now. So this is a series of test patterns. Here we have a mechanism for going full screen, and this is a test pattern that was drawn in Java using vector graphics. Here is a chip chart which shows various gray levels. Here are some color bars used for test patterns. This is some simple checker pattern, and there's mechanisms for increasing the grid and for decreasing the grid, and you can do this with Control I for increasing and Control D for decreasing. And you can see how this modifies the drawing using a simple menu item with a keyboard shortcut. This is another test pattern, and let's see now. Here are the SMPTE bars. That's the Society of Motion Picture Television Engineers bars. And here's a simple grid, also subjected to the change in patterns. Here's a strip of vertical lines. Control I and Control D will control the patterns. And if you want to see how these things are controlled, we're using these menu items in here with keyboard shortcuts. So then the question becomes, how do you do the actual drawing? And here's a mechanism for drawing. If you want to draw black on the screen, you can pass in your panel, set your graphics context to black, draw a fill rectangle based on the panel that's put in. We'll get the X and Y locations. We'll get the size, the width, and the height, and we'll draw this giant black rectangle. If somebody wants to draw bars, it may be quite a bit more complex. Here where we're drawing bars, we're still getting the X and Y location, but now we have to draw the bars with relative height and relative width. And so now we have to be very careful about the X and Y locations. It's very helpful if you're going to do this interactively to use some kind of an input device such as a mouse. But if what you're trying to do is get proportions that are correct according to some specification, you may not be able to do that. You're going to have to do some computations to get things just looking just right. Similarly, if you want to do something very complicated, things will get rather more complex in the drawing facility quickly. So here we've used this rather large dispatch, which is based on menu items. When the menu item gets selected, we change one of the options, and if the option is, well, draw a chip chart, we can see how drawing a chip chart will work with a series of fill rectangles. We keep changing the color with the invocation, in part because we used a graphics program to try and extract the information about how these test patterns look. And so that's kind of an interesting process in and of itself. So that's the that's the deal. We're essentially doing a lot of ad hoc drawing, and this type of ad hoc drawing is capable of doing fairly complex depictions of a variety of different graphics. What you might like to do is start off with something just a little bit simpler. One of the things that I've got is a 2D draw program. The 2D draw program in here is called Chapter 26 Graphics Draw 2D, and you can find a main over in here, and when you do the main method, it will let you draw simple graphics like a line, and you can change the shape. You can put in a circle if you like, and it draws a simple circle. But it also has more advanced features. For example, you can fire a ray into the circle, and you can do other things as well. For example, you can change the foreground color, and it gives you a nice little interface. We'll make a green, and now we'll draw a circle and it'll turn green, which is kind of cool. Other things you can do, which you might not expect, is you can animate the images and have them sort of bounce around, and I'm not exactly sure if that has any use for anybody, but it seemed fun. It seemed fun at the time. There's a way you can set your background color. Let's make the background color red, so we get a little contrast in there. And now I've made this thoroughly disgusting as a picture, but you get the idea. There are all these different opportunities to create a series of different shapes. The shapes are created by implementing a common base class. So this is a reasonably good example of polymorphism. Here we'll try the triangle shape, and we can see it's implementing things like a property editor and a way to intersect with other shapes, interfaces that allow it to be movable. The movable interface, as you can well imagine, requires that the object be able to be moved. Most objects in this facility are able to be moved, if not all of them. There's a compelling argument that they should all have their own custom editors. When you have a custom editor for a shape, let's see if we can find that triangle here. Here's the triangle. Then you should be able to invoke the custom editor, get out of the Add Shape mode, and then double click, and that's your custom editor. And you can see there's an element here which allows you to change the size of the shape. You can set the foreground color of the shape. Let's make something a little contrasty. We can rotate the shape around. We can shear the shape. Because that scale the shape. Here's a scale feature, and these are what they call affine transforms. The elements of what it is you can do in 2D can get quite complex. You can throw in some lenses, some spirals. You can make all kinds of complicated shapes, and that makes life kind of interesting. To see how these things are implemented, it's some fairly simple point drawing facilities. Here's the draw command. The draw command gets invoked for you because this shape becomes one of several shapes in a list. And what it enables you to do is use the graphics 2D context, and once you have that, you can start doing the so-called affine transforms, which allow you to do rotation, scale, shear, and translation. The mechanisms for drawing lines between 3 points are fairly straightforward, but we also like to draw a center for the shape and maybe give it some sort of a string representation. So when we draw the triangle, you can see the center is listed here with the integer coordinates surrounded by the parentheses. the location for that center is offset a little bit by the radius. And then what we like to do with something like this is provide a mechanism for showing the center for almost every shape, with the possible exception of the line segment doesn't show a shape. So that's the drawing program. One thing I do is I use a circle function, and I cut it into thirds, so when I draw the triangle it becomes an equilateral triangle, and I place the points in coordinates around the circle, so the points are always on a circle. And you can kind of see that here when you draw the shape. Let's see if we can draw it again. Yeah. Now if I were to draw a circle, in principle, if I'm any good at drawing circles, I can get the circle to line up more or less, or not, alongside the triangle. So that's an example of a simple drawing program. Hope you like my little demo. Thank you.